What if I told you that the greatest camera humanity ever built into space was switched off on purpose, and the very last thing it saw was so unsettling that it changed the way people think about their own lives? What if the final photographs it captured were not celebrated with fireworks or headlines, but followed by a cold, deliberate command from Earth that erased its ability to ever see again? Before we go any further into this strange, quiet, almost heartbreaking story, do me one small favor. If you enjoy stories that mix science, mystery, and human emotion, hit that like button, subscribe to the channel, and share this video with someone who loves space as much as you do. It genuinely helps more than you know, and it lets me keep making these deep dives for you. Now let's get into it, because what happened out there, billions of kilometers from Earth, is one of the most emotional moments in the history of exploration, and almost nobody talks about it the way it deserves. Picture a machine? No. Bigger than a compact car, floating alone in the endless dark. It launched in the late summer of 1977, back when disco was still on the radio and computers filled entire rooms. That little machine was called Voyager 1, and it was built for something almost unthinkable at the time. It was designed to cross the entire solar system, brush past giant worlds, and then keep going, farther than anything humans had ever sent before. And on a single day in February 1990, more than 12 years after it left home, it did something quiet, poetic, and final. It slowly turned its head, looked back over its shoulder at the family of planets it had left behind, and took 60 pictures. Just 60. That was the entire farewell. That was the whole goodbye. And barely half an hour after that final frame, engineers back on Earth began the process of blinding it forever. They did not do this because something broke. They did not do it because a wire snapped or a chip melted. They did it on purpose, calmly, deliberately, like closing the eyes of something you love, because it is the only way to keep it alive a little longer. And to really understand why that decision mattered, and why those 60 photographs still shape people to their core, you have to go back to the very beginning, when this whole adventure was just a wild idea scribbled on paper by a handful of dreamers. In the early 1970s, scientists noticed something extraordinary about the outer planets. Every 176 years, Jupiter, Saturn, Uranus, and Neptune arrange themselves in a rare cosmic lineup. When that lineup happens, a spacecraft can use the gravity of one planet to fling itself toward the next, gaining speed for free without burning a single extra drop of fuel. Think of it like a stone skipping across a pond, except each skip is a world larger than Earth, and the pond is the solar system. This trick is called a gravity assist, and on paper it sounds simple, almost elegant. In reality, pulling it off was one of the most terrifying engineering gambles anyone had ever attempted. They had to hit invisible windows in space using computers that had less power than a modern pocket calculator. One tiny mistake, one bad calculation, and the spacecraft would sail past its target and vanish forever into the black. But it worked. Voyager 1 lifted off in September 1977, and within a year and a half it was already staring straight into the swirling face of Jupiter. And what it saw there stopped the entire scientific community in its tracks. The Great Red Spot, a hurricane older than modern civilization, larger than our entire planet, was finally revealed in sharp, breathtaking detail. It was not just a smudge in a telescope anymore. It was a living, churning storm, alive and violent and ancient. Then came Jupiter's moons, and each one felt like opening a door into a new world. Io was covered in volcanoes, spitting sulfur high into space, glowing like a burning jewel. Europa had a cracked, icy shell that hinted at a hidden ocean underneath, an ocean that just might hold something alive. Every image beamed back to Earth was a small revolution. Every photograph rewrote a page of the textbook. Then, in November 1980, Voyager 1 reached Saturn, and the world held its breath again. From Earth, Saturn's rings had always looked like a single flat disk, like a pale hat around the planet. But up close, they exploded into thousands of separate ringlets, each one following its own delicate path, shepherded by tiny moons that acted like invisible cosmic sheepdogs. Then Voyager turned to Titan, Saturn's biggest moon, and discovered a thick, orange sky so heavy that the cameras could not even peek through to the ground below. Nobody had expected any of that. Nobody had prepared for it. Science was being rewritten in real time, one download at a time, one photograph at a time. After Saturn, though, Voyager 1's planetary mission was essentially finished. The path it took to swing past Titan flung it upward, out of the flat plane where the other planets orbit. It was now heading into deep, empty space, into a direction where no more worlds waited. Its twin, Voyager 2, would go on to visit Uranus and Neptune, but Voyager 1 had a different fate. It was going out, farther, deeper, into places no human eyes had ever imagined seeing. For the next decade, it just flew. No planetary flybys, no dazzling close-ups, just the silent, patient business of drifting through the void, getting weaker, older, colder with every passing year. By 1990, that little spacecraft had been traveling for more than 12 years. It was around 6 billion kilometers from home, and its power, supply, running on the slow decay of plutonium inside its generators, was fading a little more each day. Every watt of electricity had to be counted, saved, protected. You could not just flip switches whenever you wanted. Every command had to be planned like a heart surgery. And that is exactly when one man stepped in and made a request that would change everything. Before I tell you what he said, take a quick breath with me. If this story has already grabbed you, drop a comment below with just one word: Voyager. That single word tells me you are still with me and helps this video reach more space lovers across the world. Now let's continue, because what happens next is where science quietly becomes something almost spiritual. His name was Carl Sagan. He was a planetary scientist, a professor, and easily one of the greatest science storytellers of the 20th century. He was also stubborn in the best possible way. Back in 1981, when Voyager 1 was still relatively close in cosmic terms, Sagan pitched an idea that many of his colleagues brushed aside. He wanted Voyager 1 to turn around. He wanted it to point its cameras back toward the sun, back toward the tiny worlds it had left behind, and take one enormous group photograph of the entire family of planets. A portrait of home seen from the outside for the first time in human history. To some engineers, this sounded like a bad idea dressed up in poetry. The cameras had been asleep for years, sitting in the freezing dark of deep space. They were built with vacuum tubes called Vidicons, similar in some ways to the old tubes inside cathode ray televisions. If you pumped power into them too fast after such a long freeze, the glass inside could crack, the delicate parts could shatter. There was a very real chance that trying to switch them back on would kill them instantly. And even if the cameras survived, from 6 billion kilometers away, the planets would appear as tiny dots, maybe just smudges of light. Some scientists asked the honest question: what is the scientific point? Why risk the hardware for pictures that would show almost nothing? But Sagan kept pushing. For nearly a decade, he refused to let the idea die. He argued that the value of these pictures was not going to be measured in gigabytes or resolution. The value would be measured in something older and deeper: perspective. He believed that if humans could finally see themselves from the outside, from the edge of the neighborhood, they would understand something about their existence that no telescope on Earth could ever show. Them. He believed the picture would humble people. It would soften them. It would remind them, at last, how small and shared this little world really is. By 1989, NASA finally said yes, and what followed was one of the most delicate engineering operations ever performed on a spacecraft. On the 13th of February 1990, engineers began a slow, careful 3-hour warm-up of the cameras. They trickled tiny amounts of power into the heaters, lifting the temperature of those frozen Vidicon tubes gently, gradually, from near absolute zero up to around 0 degrees Celsius. 3 hours to warm up a camera, 3 hours of holding their breath. If they pushed too fast, the sudden thermal shock could crack the glass instantly, and there would be no portrait at all. And because the signals traveled at the speed of light across 6 billion kilometers, they would not know if it worked for many long hours afterward. They just had to trust the numbers and wait. Then there was the memory problem. Voyager 1's onboard computer had barely any storage compared to what we use every day today. Its total memory was around 68 kilobytes. To put that in perspective, a single blurry photo on your phone contains more information than Voyager's entire brain. Over the years, engineers had already borrowed some of that memory for interstellar physics experiments, because at that point, nobody expected the cameras to ever be used again. So new commands had to be beamed up carefully from the deep space network on Earth. Those commands would tell the camera platform exactly where to point in the endless dark, down to fractions of a degree. If the timing of any single frame was off by even a few seconds, the shutter would open on empty space instead of a planet. Each exposure lasted around 15 seconds. That does not sound like much, but at Voyager's speed, combined with the tiny vibrations from its own internal machinery, 15 seconds was just long enough to risk smearing the image. Too long, and the planet would streak across the frame like a smudge of paint. Too short, and it would drown. An electronic noise and become invisible. The margin for error was almost cruel, and once each picture was taken, it was recorded onto a spinning digital tape recorder inside the spacecraft, an actual mechanical device with moving parts, still turning after more than a decade in the radiation of deep space. That tape could hold all 60 frames, but reading them back and beaming them home over such a weak, slow radio link would take weeks. The photography began at the outer edge of the known solar system. Neptune was first. Voyager 1 had never actually visited Neptune, so it was aiming at a world it had only seen from a distance. From 6 billion kilometers away, Neptune is unbelievably dim. The sunlight reaching that far corner of the solar system is already more than 1,000 times weaker than what falls on Earth. And by the time that faint reflected light bounced back toward Voyager, the sensor was barely picking up a whisper. In the final image, Neptune shows up not as a proud blue orb, but as a soft, elongated smear of light against total blackness. A world so vast that 57 Earths could fit inside it, reduced to a faint stain of paint on the void. Uranus came next. The cameras used 3 colored filters, taking 3 separate black and white images that could later be layered together on Earth to recreate approximate color. The result was another faint streak, another quiet ghost. The same planet that had shocked scientists years earlier by tipping onto its side, spinning at an insane 98-degree angle, now looked like a nearly forgettable dot. That was the harsh lesson of the outer worlds. From far enough away, even the giants become almost invisible. Then Saturn. And here, something small and beautiful happened. Even from more than 5 billion kilometers away, Voyager's narrow-angle camera still had just enough power to catch a subtle thickening of light around Saturn's middle. Those famous rings, hundreds of thousands of kilometers wide, made of ice and rock and mystery, appeared as a faint bulge around a tiny disk. It is one of the very few frames in the entire 60-image sequence where you can actually recognize a planet as a planet, and not just as a random point of light in the dark. Take a moment right now and let that sink in. If this story is moving you the way it moves me, and you have not tapped the like button yet, please do it now. It is such a small action, but it lifts videos like this one out of the shadows and helps them find the people who need to hear these stories. All right, let's keep going. Then came Jupiter, the biggest planet in the solar system, a world so massive that every other planet in our neighborhood could fit inside it with room left over. And yet, in Voyager's final portrait, mighty Jupiter appeared as a small, slightly overexposed yellow dot. No cloud stripes, no great red spot, no moons visible around it. Just a tiny bright circle that could be mistaken for a star. This is the strange, brutal truth of deep space. Distance does not care about size. Distance does not care about beauty. Distance does not care about how important a world feels to the creatures that live on it. Give the universe enough room, and it will turn everything, no matter how massive, into a single point of light, with nothing left to say about itself. 3 planets never even made it into the portrait, and understanding why is almost as haunting as the images themselves. Mars was the first casualty. From Voyager's angle, Mars appeared as a razor-thin crescent, mostly cloaked in shadow, with only a tiny sliver catching. Sunlight. The signal was just too weak. Stray sunlight bouncing inside the camera housing washed out that faint red glow entirely. Ruined the entire mission. Humans have dreamed about walking on for over a century Mercury vanished the rest of the sequence. Mercury was left never had a chance either. It orbits so close to the sun that pointing the camera at it and too dim to appear staring almost directly into the solar glare. Even from 6 billion kilometers away, the risk was too high. And with such limited a single wrong aim could have burned out the camera's sensor targets was not something anyone could justify. This was not a peaceful photo shoot. This was a battle against distance, against light, against heat, against an aging machine, against the simple fact that space is much bigger and much sacrificed Mercury to protect the rest of the sequence. And as the cameras neared the final targets, it was too small, too dark, lifted the whole story out of engineering to appear on the sensor at all. Almost sacred. The math was clear. The lens frame aimed at Pluto would only capture noise. Venus, and with such limited tape space, highly reflective wasting frames of sulfuric acid was not something anyone could justify. Bright, this was not a peaceful photo shoot. This was a battle against distance, against light, against heat, against an aging more than 12 years in the freezing radiation of space is much bigger and much crueler. Those old Vidicon tubes were still delivering, and as the cameras neared the final target Voyager 1 would ever photograph, that lifted the whole story out of before Venus in the sequence almost that would break hearts and rewrite meaning forever toward Venus. At the moment the shutter opened, Venus was wrapped in 6 billion highly reflective clouds of sulfuric acid distance, showed our planet, every ocean, every continent, clear enough to actually see the phase of every city, every person who has ever lived, every song ever sung, more than 12 years in the freezing radiation of deep. Every dream ever dreamed, those old Vidicon tubes barely more than a tenth of a single Venus would be the last planet Voyager 1 would ever photograph. Not 1 pixel, not half Earth, pixel, just before whisper of a pixel. The planet was actually smaller than the individual at the moment the shutter elements built into the camera itself. 6 billion kilometers away. What you see in the final image is unbelievably resolved picture of entire planet. Every ocean, every diffraction, every amount of light spreading out from something almost too small. Every person who has ever lived, if the camera had been aimed even a fraction of a millimeter in the wrong direction, Earth would not have been there at all. There would have been no dot, no smudge, no camera's sensor, no mark. Not 1 pixel, not half.
And then there is the light,
just a whisper
of a
of a
pixel.
From Voyager's angle was
The planet was
only
actually
about 1 degree away
within
from
the individual
Earth in the sky.
light-sensitive
To
elements
picture that,
built into the camera
remember
itself.
that the full moon
What
in
you
our
see
own
in the
sky
final
spans
image
about
is
half
not
a degree.
really a resolved
The
picture
sun
of
was
Earth.
barely more than 2
It is the
moons
faint
away from where
action
Earth
pattern
sat
of
in
light
that frame.
spreading out from something
Light from the
almost
sun
too small
spilled
to
across
see.
the camera's internal
If the camera
barrels,
had been aimed
creating
even a
bright
fraction of a
vertical rays
millimeter in
cutting
the wrong
through
direction,
the darkness.
Earth,
And by an
there at
almost
all.
impossible
There would have been
coincidence,
no dot,
Earth happened to
no
fall
smudge,
right inside
no
one
mark.
of those beams,
just black.
Our little planet was
And then there is
cradled
the
in a
light,
stray ray of
the
sunlight.
sun,
From Voyager's
nobody planned
angle,
it, nobody
only
arranged
about
it.
1
It
degree
just
away
happened.
from Earth in the sky.
Luck placed our world
To picture
inside a
that,
beam of scattered
remember
light
that the full
at the
moon in
exact
our own
moment
sky
the shutter
spans
clicked.
about half a degree.
This is where
the
Carl
sun
Sagan's
barely
vision
more than
became
2
real,
moons away from
more
where
real than he
Earth
could have
sat in that
hoped.
frame. Light
Before
from the
we walk
sun
into that
spilled
moment
across
together,
the camera's
I wanna ask
internal
you
barrels,
something a little different.
creating bright vertical
Instead of
rays
just
cutting
liking
through.
or subscribing,
Tell me in the comments
and by an
where you
almost
were in your
impossible
life when you first
coincidence,
heard the phrase
Earth
pale
happened to
blue
fall
dot.
right inside
Was
one
it
of
a
those
school
beams.
classroom? A
Our
late
little
night
planet was
documentary.
cradled in a
A
stray
parent
ray of
telling you
sunlight.
about space.
Nobody.
I read every
Nobody arranged
comment,
it.
and yours
It just
might
happened.
inspire the next video on
Luck
this channel.
placed our world inside a beam
Now
of
let's step into that
scattered light
moment.
at the exact
The pale
moment the
blue
shutter
dot
clicked.
image that people
This
know
is
and
where
love
Carl
today
Sagan
is actually a
became
careful
real,
composite.
more real than he could
The
have
camera
hoped.
captured 3 separate frames.
Before we
using
walk into that
blue,
moment together,
green, and violet
I want to
filters.
ask you something a little different.
Each of those was just a
Instead of just
grid
liking
of numbers.
Subscribing,
Grayscale ghost.
tell me in the comments where
Back
you
on
were in
Earth,
your life
months
when you
later,
first heard the phrase
researchers at the
pale
Jet
blue dot.
Propulsion Laboratory
Was it a
carefully
school
lined those
classroom?
frames
A
up
late
and
night
colored them,
documentary.
reconstructing
Parents
something
telling you
close
about
to what a
space.
human eye would perceive.
I read every comment.
And yours might
tint,
inspire the next
one that
video
makes
on
the
this
dot
channel.
feel like home.
Now let's
came from
step
the
into
blue
that
filter
moment.
from the
Very
pale
wavelength
blue
of
dot
light our
arch that
atmosphere
people
and
know
oceans
and love
reflect
today
best.
is actually a careful
When
composite.
Carl Sagan first saw
the
the
camera
finished
captured
picture,
3 separate
he did
frames
not see it
using
as blue,
scientific data.
green, and violet
He saw
filters.
mirrors.
He saw a
Each of
truth
those
that
was
humans
just a
had
numbers,
spent
thousands of years
grayscale
avoiding.
ghost.
And in his
Back on
soft,
Earth, months later,
unforgettable voice,
researchers at the Jet
he described
Propulsion
what that
Laboratory
dot really
carefully
meant.
lined those
He
frames
said
up
that
and colored
on that
them,
tiny mote of
reconstructing
dust
something
suspended
close
in
to
a
what
sunbeam
an eye would perceive.
lived everyone you love,
That blue tint,
everyone you have
the
ever
one that
heard
makes
of.
the dot
Every
feel like
human
home,
being, whoever was,
came from the blue filter,
every
from
king
the
and
very
peasant,
wavelength of
every
light
young
our
couple
atmosphere
holding hands under a
reflect
street lamp,
best.
every mother tucking
When
her
Carl
child
Sagan
into
first
bed,
saw the finished
every
picture,
inventor,
every
he did not see
explorer,
it
every
as
teacher,
scientific
every
data.
soldier, he saw a
every
mirror.
saint, every
He saw a
sinner,
truth
every
that
hero, every
humans
villain, all of them
spent
together
thousands
on
of
a
years
speck
avoiding.
of dust
And in
floating
his
inside a
soft,
great,
unforgettable
enveloping
voice,
cosmic dark. He described what
He
that
reminded
dot
us
really meant.
that we have nowhere
He
else to
said
go,
that on that
at least
tiny
not in
mote
any
of
near
dust
future.
suspended
There's
in
no
a
backup
beam,
planet floating
lived
quietly
everyone you
next
love,
door. There's
everyone
no
you
plan
have ever
B.
heard of.
There's only
Every
this
human
pale,
being who ever
fragile,
was.
beautiful dot.
Every king
And everything
and
we have
peasant,
ever done,
every young
everything we have
couple
ever
holding
loved,
hands under a street
has happened here.
Mother
He
tucking
said
her
the photograph
child into bed,
underscores our
every
responsibility
inventor,
to
every
treat one another
explorer,
more
every
kindly
teacher, every
and to
soldier,
protect this only
every
home
saint,
we have ever known.
every sinner, every hero,
He wrote
every
those
villain,
words in
all of them together
1994
on a speck
4 years after the picture was taken,
floating inside a great,
and decades
enveloping
later, they
cosmic
still feel
dark.
like a gentle hand on
He
the
reminded
shoulder
us
of humanity
that we have nowhere else to
asking
go,
us to
at least not in any near
pay
future.
attention. There's no backup
Then, at exactly
floating quietly next door.
4:48
There's no
GMT
plan B.
on Valentine's
There's only
Day,
this pale,
1990.
fragile, beautiful
The shutter
dot.
closed for the last
And
time.
everything we have ever
The
done,
final frame,
everything we have
number
ever
60,
loved,
was not a
majestic
goodbye.
goodbye.
It was not
He
a
said the
beautifully
photograph
framed planet.
underscores our
It was a
responsibility
wide,
to
messy
treat one
shot
another
near
more
the
kindly
direction
and
of
to
the sun,
protect this only
filled
home we
mostly
have ever
with
known.
sensor noise and
He
scattered
wrote those
light.
words in gray and black chaos, an unceremonious ending. No trumpets, no fanfare, just a soft click, then silence, then drifting. For the next 34 minutes, the cameras stayed technically powered on, doing nothing, just floating along with the spacecraft. And then, back in California, engineers made the decision that had always been waiting at the end of this story. Voyager 1's brain, that tiny 68 kilobyte memory, could not hold everything at once. The next stage of its life, the crossing into interstellar space, needed new software. Software that would prioritize the instruments just still capable of returning meaningful science, then drifting from beyond the solar system. For the next 34 minutes, the cameras stayed technically powered on, the cosmic ray sensor just floating along. There simply was not enough room in that little memory to hold both the imaging code. Engineers made the new interstellar code side by side. Story. Something had to go. Voyager 1's brain, and so they overwrote the parts of memory that ran the cameras. Everything at once. The code that had shown us Jupiter's storms up the crossing into interstellar space, that had shown us Saturn's rings dancing in the dark. Software that would prioritize the instruments still capable of returning meaningful science, permanently gone. On the solar system, Voyager, the magnetometer, literally plasma wave detector, take a picture, cosmic ray sensor, the camera platform was locked into not enough room in that little memory to software that image turned incoming light and the new interstellar code side by side existed inside the spacecraft to go. And even now, so 35 years later, parts of there was no way to bring it back. The operating system for the imaging science is storms
gone.
up close.
You cannot
that had
simply
shown us
beam up
Saturn's
the new
rings
version,
dancing in the dark,
because there is
that had
nowhere
just
in that
captured the
fragile
pale
memory
blue
to store
dot
it.
was
Then,
erased to save even
white.
more power. The
Permanently
engineers
gone.
turned off the heaters that
Voyager
kept the cameras
1.
on. Without
Completely
those heaters,
forgot how to
the
take
camera
a picture.
temperatures dropped past
The
200
camera
degrees
platform was
below
locked
0
into a
Celsius.
fixed position.
The lubricants
Software
froze,
that
turned
the shutters
incoming
froze.
light into transmittable
Somewhere
data
inside those
no
old
longer
Vidicon
existed
tubes,
inside the delicate
craft.
glass, almost certainly
Even
cracked
now,
from the brutal
35
cold.
years later,
Those
there's
cameras
no way
are
to bring
still
it back.
bolted onto Voyager
The
1's
operating
instrument
system for
room
the
today,
imaging science
35
is
years
gone.
later,
You
sailing
cannot
further
simply
and further
beam
out
up
into the
the
dark,
version,
because
they are not
there is
sleeping.
nowhere in that
They're not
fragile
resting.
memory to store
They're
it.
dead.
Then,
cold,
to save
cracked,
even more power,
blind.
the engineers turned off
into
the
monuments
heaters
of a moment
kept
that will
cameras
never come
warm.
again.
But
Those
those
heaters,
heaters,
the
camera temperatures dropped
truth
200 degrees
below
below 0 Celsius.
By killing the cameras,
the lubricants
NASA
froze,
gave Voyager
the shutters
1
froze,
something priceless.
somewhere inside those
Life.
old Vidicon tubes.
The
tiny
delicate
amount of
glass
power
almost
reclaimed from
cracked
those
from the
heaters and
brutal cold.
electronics gave
Those
the cameras
cameras
the
are
still
still
bolted
bolted
onto
needed to
Voyager
keep
1's
going.
instrument boom today.
That extra energy
35
helped
years
Voyager
later,
1
sailing
cross
further
the
and further
termination
out into the dark.
2004.
But the region where the sun's
not
solar
resting.
wind starts to
They're
weaken
dead,
against the pressure
cold,
of interstellar
cracked,
space.
blind.
It helped Voyager
Turned
1
into
monuments
monuments
of
of
a
a moment
moment
that will
in
never come
2012.
again.
But
Here's
here's
the
the doorway
painful,
between our solar
beautiful
system and the space between the
behind all of
stars.
this.
That
By
crossing
killing the
made
cameras,
NASA
the
gave
first
Voyager
human-made
one
object
ever
something
to enter
priceless.
interstellar space.
Life.
If those
tiny
cameras
amount
had
of
power
power
reclaimed
reclaimed
from
for
those
even a few
heaters and
extra
electronics,
months,
Voyager 1
spacecraft
might have run out of
engine it needed
power
to keep
before ever
going.
reaching that milestone.
That extra energy helped
It
Voyager
died
1
before touching
cross
true
the
interstellar
interstellar
shock in
space.
2004.
So we made a trade.
The region where the
traded
sun's
our eyes
solar
for the
wind starts
stars.
to weaken against
We gave up
pressure
the
of
ability to
interstellar
ever see
space.
anything again
It
through
helped
Voyager
Voyager
1
1 cross the
in
exchange for the
heliopause in
chance to
2012,
keep listening to the
true doorway
whispers of the
between our
universe
solar
from the
system
other
and the
side
space
of the
between the
neighborhood.
stars.
That
Today,
crossing made
Voyager
1 is more than 24 billion kilometers from Earth. The sun, once the brilliant center of its universe, is now just another bright point of light in a sky full of stars. The signals from Earth take more than 22 hours to reach it, even at the speed of light. Only a handful of instruments still work. The magnetometer still whispers back data about the magnetic fields of interstellar space. The plasma wave subsystem still measures the density of the strange thin gas that fills the region between the stars. The low-energy charged particle detector still catches echoes of cosmic rays born in supernova explosions from billions of years ago and billions of light years away. And even now, engineers back home keep pulling off small miracles. In recent years, they carefully reactivated old thrusters that had been sleeping for decades, just to help keep Voyager's antenna pointed toward Earth. They worked around corrupted memory chips, using clever software rerouting, coaxing the spacecraft back into sending clean scientific data. The low-energy charged particle detector still catches echoes of cosmic rays born in supernova hardware built in the billions of years ago, using billions of light years away before the internet. Before engineers back home keep pulling off small miracles, working on the mission today, they carefully reactivated old thrusters. It is one of the most quietly heroic engineering stories of our lifetime. Just to help keep Voyager's antenna. The cameras themselves remained frozen. They worked around corrupted memory chips using clever software in 1990, coaxing the spacecraft back and sending clean scientific data after months. They are physical fossils, garbled noise, silent artifacts of a moment when a species decided for once to look back at itself instead of forward. In about 40,000 years, Voyager 1 will drift within about 1.6 light years of a small star in the constellation of Camelopardalis. By that time, the spacecraft will have been dead for tens of thousands of years, its plutonium long since exhausted, its systems long since gone quiet. It will be a ghost ship gliding through the galaxy in complete silence. Attached to its hull is the famous Golden Record, a gold-plated copper disc engraved with sounds and images from Earth. In about 40,000 years, Voyager to any traveler or civilization 1.6 light years of a small star carries greetings in many languages of Camelopardalis. Laughter, by that time, the beating of a human spacecraft will have been dead for tens of thousands of years. Beside that record, its plutonium long since dead cameras, its systems long since gone frozen in place. It pointed forever in the direction they last looked. Galaxy. The Golden Record tells any future finder who we were. Attached to its hull is the famous Golden Record. A gold-plated copper disc engraved with sounds and images from Earth. Still on our message in a blue dot sent to any traveler or civilization to see our home from the outside. It carries greetings in many languages, into the dark, whale songs, and on that one extraordinary day in February 1990, for the first and only time in the entire history of those two dead cameras, we turned around and looked back at the beginning of everything we have ever known, pointed forever in the direction ourselves as we truly are. The Golden Record tells a future finder who we were. A soft, quiet dot, something else, cradled inside a beam of scattered sunlight, floating in a vast and silent ocean pale night. Dot and simply exist. And then, calmly, wanted to see our home from the outside. We closed our eyes at least once before stepping into the dark. Because sometimes the greatest act of exploration is not looking forward. Sometimes the first, it is having the courage to look back one last species, understand exactly where you came from, at the beginning of everything we have ever, and then walk deeper ourselves as we truly never to see home again. Tiny, fragile. If this story touched you the way it touched me, quiet dot, do not let it end inside a beam of scattered sunlight. Like this video, subscribe to the channel if you have not already, and share it with someone who needs to be reminded just how small, how shared. We closed our eyes and kept going, protecting our pale blue dot. Because really sometimes the greatest act of exploration, we may never send eyes that far out again in our lifetime. Sometimes it is having the courage to every single day, one last time, to take better care of, understand exactly where you came from. Whisper.